Hey guys, welcome back to my YouTube channel. In our previous video, we have learned about some basic concepts of differentiation. So in this video, we are going to learn about differentiation of trigonometric equations, chain rule, product rule, and quotient rule of differentiation. So first, let's start with derivatives of trigonometric ratios. As we have learned in our previous classes, we have 6 trigonometric ratios. Those are sin x, cos x, tan x, secant x, cosecant x, and cot x. These 6 formulas are very important while we are solving the questions related to trigonometric ratios. So first, let's see. The first formula is d by dx of sin x is equals to cos x, and d by dx of cos x is equals to minus sin x. So with these two formulas, we can say that sin x and cos x are a pair. Like, these are the tips through which we can remember the formulas easily. So similarly, here we have tan x and secant x. These two are a pair. That means they appear in each other's formulas. Similarly, cosecant x and cot x are a pair. This does not apply everywhere, but in case of differentiation, this is a small trick to remember the formulas. And one more thing we can observe is, whenever there is c in the left hand side, like cos x, cosecant x, and cot x, we can observe a negative sign in the right hand side. This is another tip. Okay, so let's just read out all the formulas. So d by dx of sin x is cos x. d by dx of cos x is minus sin x. d by dx of tan x is equals to secant square x. d by dx of secant x is equals to secant x tan x. d by dx of cosecant x is equals to minus cosecant x cot x. d by dx of cot x is equals to minus cosecant square x. So let's solve some simple examples for better understanding. So the first equation we have is y is equals to cos x plus sin x. So when we are finding the derivative, that is dy by dx, we can split this into d by dx of cos x plus d by dx of sin x. So the derivative of cos x is minus sin x, and derivative of sin x is plus cos x. We can rearrange it and write it as cos x minus sin x. So this is the answer. The next question is y is equals to cos x minus secant x. So dy by dx is equals to d by dx of cos x minus d by dx of secant x, that is minus sin x. So whenever there is c, you will get a minus sin x minus secant x tan x. You can simplify this if needed by taking minus common and write it as minus of sin x plus secant x tan x. Next question is y is equals to cosecant x plus tan x. Again, we can observe that there is a c, so you will get a minus term in the derivative. dy by dx is equals to d by dx of cosecant x plus d by dx of tan x, that is minus cosecant x cot x plus secant square x. We can rearrange it as secant square x minus cosecant x cot x. So this is about the trigonometric ratios. Make sure that you remember all the 6 formulas thoroughly so that you can be quick and accurate while doing the derivatives. So the next concept we have is chain rule. In this chain rule, what happens is we have a function in which we have another function related to x. For example, 2x plus 1 whole cube is one function. Inside that, we have another function that is 2x plus 1. So let's understand it by solving the question. So when we are finding the derivative of this term, first what we do is, first we find the derivative of 2x plus 1 whole cube. That is, we take this term as a single term. We take 2x plus 1 as a single term and then we multiply that into the derivative of the inner term, that is 2x plus 1. So it will be 3 into 2x plus 1 power 3 minus 1 into derivative of 2x is 2 and derivative of 1 is 0. So we get it as 3 into 2x plus 1 whole square into 2, that is 6 into 2x plus 1 whole square. So whenever we are following chain rule, in this chain rule we will differentiate all the functions with respect to x. For example, we'll do another example for better understanding. Here sin x, generally sin x is one function. So when we have a term called sin square x, what we do is we take this as sin x whole power 2. So when we are differentiating, first we'll differentiate the whole square over here, then we will differentiate the sin x. So differentiation of sin square x will be 2 into sin x. This is differentiation of the whole square. And now we multiply that with the differentiation of sin x, that is cos x. So it will be 2 sin x cos x. Okay, this is the differentiation of sin square x. Now let's see the differentiation of another similar kind of question, but here in place of x we are having one more function, that is x power 5 plus 1. We do the same thing. We will multiply again the derivative of x power 5 plus 1. So dy by dx is equals to 2 into derivative of the whole square first, sin x power 5 plus 1. Now the derivative of sin x into cos x power 5 plus 1. Now we have to find the derivative of the other terms. That is x power 5 plus 1. So into derivative of x power 5 is 5 into x power 4 plus 0, because derivative of constant is 0. So the answer we will get is 2 into sine x power 5 plus 1 into cos x power 5 plus 1 into 5x power 4. So this is the simplest form. If you want to simplify it more, you can do it, but this thing is enough. Let's solve another example. The function is y is equals to tan square of cot 2x. So first what we do, we will solve the whole square. dy by dx is equals to derivative of square is 2 into tan of cot 2x. We have power 1, does not require to mention even, into, now we have to find the derivative of tan. Derivative of tan is secant square cot 2x, because in place of x we have cot 2x. Now we have to derive for cot. Derivative of cot is minus cosecant square x. In place of x we have 2x. Now we have to do the differentiation of the inner term, that is 2x. It will be 2. This is a bit lengthy but easy if you understand it. So here we have 1 2, here we have 1 2. It will be 4 into tan of cot 2x into, everything is multiplication, secant square of cot 2x into, there is a minus sign, so I am placing a minus in the front, and cosecant square 2x. If you want, you can do more simplification using the formulas of trigonometric ratios. So the next concept we have is product rule. Initially in our previous video we have learned that if there is an operation called addition or subtraction between two functions, we have simply derived that by this formula, d by dx of u plus or minus d by dx of v. But here we are having multiplication between them. So when there is an operation called multiplication in between, we use this specific formula. That is dy by dx is equals to u into dv by dx plus v into du by dx. This is a pre-derived formula which we use for two equations which are in multiplication. So let's understand this with the help of an example. Here we are having the function y, which is x into sine x. Here we take x as u and we take v as sine x. So as we have the formula, dy by dx is equals to u into dv by dx plus v into du by dx. So first the value of u is x. So x into derivative of sine x, that is dv by dx. Derivative of sine x is cos x plus v. V is sine x. So sine x into derivative of u, that is derivative of x. Derivative of x is 1, as x power 1 minus 1. It is x power 0, that will be 1. So at the final answer we will get is x cos x plus sin x. So with the help of UV rule we can simply get this answer. We'll solve another question. Here the value of u we are having minus x square, and the value of v is cosecant square x. So, and the value of the derivative of the each term, du by dx is equals to minus of 2 into x power 2 minus 1 here. So it will be minus 2x. And the derivative of the second term, that is cosecant square x, we can write it as, using the chain rule, we can solve it as 2 cosecant x into differentiation of cosecant x, that is minus cosecant x cot x. The final answer we will get as minus 2 cosecant square x cot x. Now we will substitute these formulas in the formula we have, that is d by dx of uv is equals to u into dv by dx plus v into du by dx. So that will be u is minus x square into minus 2 cosecant square x cot x plus v into, that is cosecant square x into du by dx, that is minus 2x. So if you're comfortable, you can do the derivation right here after writing the values of this formula. But for better understanding, I have separated it and written it like this. So minus into minus is plus 2x square cosecant square x cot x minus 2x cosecant square x. This is the final answer which we get for this question. So the last topic for this video is our quotient rule. In the previous examples, we have seen that the operation is multiplication. Here the operation is division. So when there is division, there is a certain formula, that is dy by dx is equals to v into du by dx minus u into dv by dx divided by v square. So these are the predefined formulas which help us a lot while solving difficult kind of questions. So this question is, here we take the value of u as secant x and v as x square. This question actually has two methods in which we can solve. As we want to learn the example of u by v, first we'll solve it in this way. So the formula is v into du by dx. So x square into derivative of secant x is secant x tan x minus u into, that is secant x into derivative of v, that is 2x divided by v square, that is x square whole square. So the final answer you will get is x square secant x tan x minus 2x secant x divided by x power 4. By simplification, you can do it another way by taking x common over here and here. X secant x tan x minus 2 secant x divided by x power 4, and you can cancel it. So the answer you will get is x secant x tan x minus 2 secant x divided by x cube. So this is one method. Another method in which you can solve this as, you can rewrite this equation into 1 by x square into secant x, which can also be written as x power minus 2 into secant x. So here you can see that it is in the form of u into v. So you can apply uv rule, or which is also called as product rule. You will get the same answer using both the rules, whether it is product rule or quotient rule. Try this in this method and do comment in the comment section. So the second example we have is sine of ax plus b divided by cos of cx plus d. Here our u is sine of ax plus b and v is cos of ax plus b. So we'll apply the quotient rule, that is v into du by dx minus u into dv by dx divided by v square. So the value of v is cos into ax plus b, and the derivative of u, du by dx, that is derivative of sine ax plus b. I'll write it down here. Du by dx is equals to, derivation of sine is cos. So cos ax plus b, and the inner derivative of ax plus b, that is a. So here we'll write it down, a into cos of ax plus b minus, we'll find the value of dv by dx also. dv by dx will be derivative of cos, that is minus sine ax plus b. Sorry, this is cx plus d, so this will also be cx plus d into c. So we'll just substitute the value over here. U into, that is sine of ax plus b into minus c sine cx plus d divided by v square, that is cos square cx plus d. So let's simplify the equation. A into cos ax plus b into cos cx plus d. I forgot to change it. Minus, here there is a minus over here and there is a minus over here. So minus into minus will be plus, sine of ax plus b into sine of cx plus d into c divided by cos square cx plus d. If you want to simplify it further, you can simplify it. So that's it. This is the differentiation part. So in this video, we have learned about the quotient rule, product rule, and differentiation of the trigonometric ratios. Hope you like the video. Don't forget to like, share, and subscribe my videos, and hit the bell icon for your notifications. Thank you.